Hello viewers, welcome back. In the previous video we saw what are data types, what are their various applications, what are their various classifications, and how they are used in a program. We saw the theory behind it. We also saw how the variables are created. Well, in today's video we are going to go one step ahead and perform some practical experiments. We'll see some hands-on examples where we will get to know more about what are data types, what are the various kinds, and how the variables are declared, what are the scope of the variables, whether it's local, whether it's global. We'll see all of that in these 4 to 5 different programs. So without wasting much time, let's get started with the very first program. The very first program that I have in front of you is going to show me the size of different data types. As we saw in the previous video, there are different kinds of data types. For example, the basic or the primitive data types, the user defined data types, and the derived data types. So in this case, we are going to focus on the basic data types, that is int, float, char, and double. I told you in the previous video also that generally or typically the size of int is 4 bytes, float could be 4 bytes, double could be 8 bytes, and char is 1 byte. Okay, so we'll see that by running this program first, and then I will walk you through what exactly this program is all about. So if I simply click on this and run this C++ file, if I go to this console, you can see over here size of int is 4 bytes, size of float is 4 bytes, size of character is 1 byte, and size of double is 8 bytes. So this is what it should have shown to me ideally. So now let me break it down. Let me break down the entire code for you, and you will be in a position to understand how this works. So the very first thing over here is we know the very first line, that is hash include stdio.h. These are basically the preprocessor directives. So we are including the standard input output library, because if we don't include this, we won't be able to print anything from line number 3 to 6. That is, we are printing something on the console, we are taking some kind of input, or we are showing some kind of output. For those operations we need this library called standard input output. This is basically a header file which ends with .h, right? So we are going to make use of a file from this header file, a function basically from this header file, that is nothing but printf. So printf is a function which belongs to stdio.h, and to call the printf function, we need to import that header file. That is the first line that we are doing over here. Second line is basically the int main. So this is the main function, or we can say the main body of my entire code begins from here. The execution of any C program begins from the main method or the main function. Okay, so this is what we are doing, and this is nothing but the return type or the data type of this main function, which is in this case int. If we are using Turbo C, we would have been using void main instead of int main. But now I'm showing this on IDE, specifically Visual Studio Code. So I'm using int main, or it won't work. It will give some error, right? So int main, and this is where I'm printing all these values which you can see on your console. That is size of int, size of float, size of char, and size of double. So this is how we print it within double quotes. Size of int colon, this is nothing but used for formatting. %zu, this is what is important in this case. %zu is basically the format specifier which corresponds to an unsigned size operator, or we can say unsigned integer. A size cannot be negative, right? So we don't need the sign for it, and that is the main reason that we are going to use unsigned integers. So this line number 3 is basically the printf statement where we are displaying the size of the int, size of the float, size of the character. So line number 3 to 6 are basically the things which you can see on your console. Line number 3 is printf size of int. So we know that whatever we want to display, we need to write that inside these double quotes. So whatever you can see over here, that is what is going to be printed on the screen. So size of int, and then a colon. This colon is nothing but used only for formatting. You can omit this also. This is not something which is compulsory. You can add dashes also. It will show you the same kind of thing. The output won't differ much, only the formatting will differ, as you can see on your screens. I will just show it to you. See over here, only the formatting differs, rest everything remains same, right? Now this %zu is nothing but, it's called as the format specifier. Now what we actually want to do is, just pay attention over here. anything between these double quotes is going to be printed on the screen. But what about this? What about this comma? Anything after this comma is going to do some operation, and that result is going to be displayed over here instead of this percent sign, whatever it is, percent %u, percent %d, percent %l, we will see that. So in simple words, this percent %zu is going to be replaced by some output thrown by this function over here. So size of int is again a function which is going to compute the size of this int data type. Whatever is the answer, that answer is replacing this percent %zu, or that answer is going to replace this percent %zu. In simple words, this percent %zu stands for unsigned int, as size is something which doesn't have any negative values. -4 or -8 doesn't matter. It's basically the size of the container. So we want the size to be positive only, and for that reason, whatever be it, we are going to display that as unsigned long, because as you can see, if I keep my mouse over here on top, it gives me the format. It is unsigned long, right? So that is the main reason I'm going to use percent %zu. So what happens is you can use percent %u, percent %lu, percent %llu, whatever you want to use, but to keep it safe so that the same code can run on multiple different platforms and the portability is not an issue. So for that purpose, I'm going to use an unsigned attribute over here so that I can use the same code on multiple platforms as well, and it will give me the same result everywhere. So for safety concerns and for portability concerns, we can use this percent %zu over here. Clear? So that is going to give me the result as size of int is going to be 4 bytes. In the same fashion, size of float will give you some result, and that is again going to be 4. So that 4 is going to replace this ZU. In the same fashion, size of character will be 1, and that is going to replace this ZU. Size of double is going to be 8, and that is again going to replace this ZU. So that is our very first program. As you can see, size t is an unsigned integer type defined in C and C++ that is used to represent the size of objects in memory. Right? So it depends upon whether your machine is a 32-bit machine or a 64-bit machine. So if in my case it is 4 bytes, 1 byte and 8 byte. So it depends whether your machine is a 32-bit machine or a 64-bit machine. So you can run this program on your machines and let me know your output in the comments. I would be really glad to find your answers. And if you're having any doubts, you can let me know in the comment section. I would be really very happy to answer your questions as well. So this was a very quick video. In the next video, we'll see some more programs. So stay tuned. Take care. God bless you.